Ciao friends! In this Unplugged video, I want to talk about how DAX.do works. A few weeks ago, we launched this DAX.do service, which allows you to write in a browser DAX code and test it with databases that are available online without having to install anything. So DAX.do had a great success, and we also received several questions. And I would like to answer to these questions, also explaining how DAX.do works, because this will enable you to understand what is behind DAX.do and what is required if you want to create a similar service, or just because maybe you are curious to understand how it works. So DAX.do is the website that probably you have already seen. You see that I have this DAX.do website where I can select a database here, and I can write a DAX expression, run the DAX expression, and see the result. Now, this is a playground where I have to write a DAX query. And for this reason, we use the DAX.do as a way to run sample code, for example, in DAX Guide. You will find that if you go to DAX Guide and you browse in several examples, we have this try it button that allows you to test the code in DAX.do. Now, in order to run this query, of course, DAX.do, which is a website, has to connect to analysis services or Power BI. So how does it work, and how is it possible, or is it possible to connect DAX.do to other databases? So let me start to explain what is behind the scene. So DAX.do is basically a web application, a website, but actually when you open the page here in DAX.do, you download a JavaScript application in your browser. And this application basically has to connect to a remote database, an analysis services database. So let's go to this whiteboard where I can try to describe what we have. So let's start from the web page where we have DAX.do. Okay, so this is let's say DAX.do is my is an application in my browser. So let's say that this is my web browser. Doesn't matter if you have Edge, Chrome, or whatever else. Now DAX.do is running here, but of course it has a user interface that allows me to write DAX code. And the database where I'm connected to is a database that we prepare in advance and that you can consume, but you cannot connect to any database that you want. So let's say that we have here Contoso, or we have today two databases. So there is another one which is called DAX Guide, and potentially we could extend these databases in the future. But these databases have to be analysis services databases or Power BI datasets. So we have an instance of analysis services running in the cloud, and technically this is Azure Analysis Services, but so Azure AS. So today we have this situation. So there is a service, an Azure service that is running these databases for us. However, the DAX.do web browser cannot connect directly to Azure AS. I mean, it could, but this would create a large requirement, and the effort required to do that will require having the complete communication stack in your browser. And if you heard about news that was announced 1 or 2 weeks ago, is about the client application, the client libraries for .NET Core. And actually this is something we used just to solve this problem. And let me explain you how this works. So the browser is a JavaScript application, and what we don't have either is a direct connection between the browser and Azure Analysis Services or Power BI Premium if it was the case. So what is really happening is that we have something in the middle. You don't see this, but it's necessary to run DAX.do, which is a service. And the service actually receives the request made from DAX.do, for example, when I run a query here, the request to run a query is received by this service, and this service actually sends the request to Azure Analysis Services. This makes it possible to communicate with the web browser application that technically uses a sort of REST API with Azure Analysis Services, which has a more complex communication protocol in order to transfer information about the metadata, the structure of the database, and also in order to run the query. So what happens is that here there is something that receives a request, REST API, sends the request to Azure Analysis Services, and this is technically something that uses an XMLA endpoint, receives the result of the request and transfer the result back to DAX.do. Now, this middle tier is a structure implemented with Azure Functions, and it is our DAX.do service. So let's say that there is a service, DAX.do service here, and this service is implemented in C# and in .NET Core. Technically, the infrastructure we use to run this is an Azure function. I think 2.0 or something like that. Why this is important? This service has a cost. Azure Analysis Services has a cost. So even though the service is completely free, we have to keep these services running just in order to provide a service. So we try to squeeze the cost the more we can just to avoid paying a huge bill just to create this service that we like it, but we cannot afford spending thousands of dollars every month just to run a few queries. So we try to implement the service in a way that is relatively inexpensive. We try to reduce at the minimum the workload on Azure Analysis Services just to keep the instance of Analysis Services the less expensive we can. So this service in the middle, this DAX.do service, has several purposes. It receives the request and sends the data back to DAX.do in a way that can be understood by the JavaScript client. So let's say that it translates the request from one format to another, just to say. But the second reason why we created this service is because we can create a very aggressive cache system so that we don't have to run the same query multiple times if we know that the result of the query will be always the same. And so this way we reduce the workload for Azure Analysis Services. And at the same time, using Azure Function to 0, we have a very low cost for keeping the service online because the service can scale very, very well, but when it is not used, it reduces the consumption a lot. And the billing is based on the number of requests, so there is basically no cost just in keeping the service active. It just depends on how much traffic it receives. So for this reason, if we didn't have the library for analysis services for .NET Core, we would not have been able to use Azure Function to 0, and we would have forced to use Azure Function with .NET Framework, which is possible, but it is more expensive because the footprint and the cost for keeping the service active would have been higher, or the cost for keeping a web application active 24/7. So if you have seen, this is an important announcement. .NET Core libraries are very important. It's just because they enable this kind of scenario. And so if you want to create a middle tier that connects to Azure Analysis Services, you are no longer forced to use .NET Framework, which implies using Windows. Basically, the .NET Core library can be used on Linux or on Mac if you want. So the barrier of having Windows to connect to Analysis Services does not longer exist, and this is a big news. So this is what is happening, but there is something more. As you can imagine, if I run the same query twice, what happens? So let's go back to the demo machine, and here you see that I just ran a query, and I see the result here. When I click run again, you see that this result is still the same. Now, in this particular case, because I'm executing the same query that has been executed, that is visible here in the history, basically the client side already has a cache that does not have to send the request to the real server. But if I change something here, for example, if let's say, I just changed the name here. I put a dash here and I click run. Now the query is no longer the same, and this enforces the request made to the service that is executed. Now, so there is a first cache client side, but then there is a cache server side. In our Azure function, we have a cache system. Now, we could be very aggressive. At the moment, we didn't implement all the possible techniques, but one important technique we implemented is the following. If I go back here, you see that when I have the button try it, what happens? The code that you see here, the code for this example, is copied into the DAX.do window and it is executed. Well, actually, this is not entirely true. When I click try it, you see that the URL includes this identifier of the query. And what happens is, because this is the same query I already ran weeks before, the service keeps the result of the query and not just the definition of the query in a separate storage. So when I retrieve this query, actually the query is not really executed. The previous result of the query is actually retrieved from another storage and it is returned to the client. So if I go back to to this diagram, so let's say that in DAX guide, so let's see the scenario that we have. So we have DAX guide here, but this could be any website, right? Because you can save the URL for DAX.do, for a query in DAX.do in your blog post if you want. You can just save this URL with a share button you have in DAX.do. So DAX guide sends a link to DAX.do. DAX.do opens the query, but actually in order to do that, DAX.do sends a request that is a load query, right? And load query sends this specific identifier that says, I want to load this query. Now, when DAX.do receives the request, what happens is that actually DAX.do retrieves from a storage. Let's say that this is a blob storage. Technically, this is called the blob storage on Azure. Storage. So here, this request retrieves the result and the query. So let's say that there is the DAX query here and there is the result. So these two elements are transferred back here and the result is sent back to DAX.do. So only when I change the query, at that point, the query will be sent to Azure Analysis Services. And guess what? Many times when you want to try the query, the first execution does not have to be a real execution. And this allows us to lower the number of requests that are actually sent to Azure Analysis Services. Of course, when I save the query, so when I go in DAX.do, and let's say that I clear this content and I write evaluate, and I write 1, 2, 3, 4, 5, something like that. So I create a query. If I run this query, this is a real query executed in real time, and then I want to share this query with someone else. When I click this button, share, what happens is that when I click the button save and share, the query and the result is stored in the blob storage that you have seen before, and I have this URL, this link that allows me to restore the query. And if I have this code that I will hide from the video so that people don't use the same code, this code allows me to modify the query. Imagine that I realize, oh, I made a mistake in the query, I want to fix the result or fix the query. I don't want to change the link because I already published the article. I can edit an existing query and I can modify the content by using this special link that has a special identifier at the end. Now, what happens when I use this? Let's go back here. At this point, when I have the save query is a similar request. So let's go back one moment here. So, okay, this way. So let's say that I create my query here. Let's write here save query. What happens? The save query stores in this storage the DAX code and the result. Of course, in order to get the result, save query actually executed the query here, gets the result in the storage here, and then the result obtained here is returned to DAX.do. And so when you save the query, the service actually stores data in the blob storage and actually execute the query to make sure that we have the latest version of the result that we want to save in the storage. So more or less, this is the structure we have. So we have seen that there is a complexity behind DAX.do in order to run the service, but this is important because now I want to answer to a few queries. And the first query we often received was, can I connect DAX.do to my database? So let's try to answer to this query looking at the architecture here. So let's clear something here. So let me remove the code here, and let's just use this visualization here. Here we go. So let's say that you have your own database. Your own database is on another service. So let's say that you have your Power BI dataset here, okay? Now, technically, we could connect DAX.do to your database, but this would be not safe from many point of views because, as I said, DAX.do, the web application, cannot connect directly to Power BI or to analysis services. It has to invoke a service that has to authenticate a user to the Power BI dataset. Now, guess what? This service is written by us and it runs with the SQL BI resources. So, assuming that we would like to provide this service for free, but you should provide the user credential to access to the content of your database to a service that we run. And so technically we could access to your data at any time at that point because there would be no control over, or at least you should trust us that we don't use your user credential for other purposes. So it would not be safe. And by the way, it would require a third-party service, in this case our service, to access to the real data. So the consequence of that is that we will keep databases available for DAX.do, like Contoso, DAX Guide. We could extend them at a certain point, but just for educational purposes. But the goal of DAX.do is not to be a general purpose client so that anybody can access to any database, because as I said, the architecture requires a middle tier that requires a complete access and complete trust to access your data. So probably what you don't want is someone else that has full access to your data. And a similar question was, can DAX.do replace DAX Studio? No. For many reasons. One is the reason that I already explained. Another reason is that if you think for a moment, DAX.do doesn't have many of the features that you have in DAX Studio. For example, DAX Studio has the ability to monitor performance. DAX.do doesn't have any of these features, and it would be a waste of time trying to implement in DAX.do a similar set of features. I mean, nothing is impossible, but it would be a huge investment, that cannot be justified for any reason. Yeah, maybe that the look and feel of DAX.do can be, more clean than other user interfaces, but believe me, we will spend time optimizing the UI of DAX Studio as soon as we have time. So that is another, we can obtain that result with other means. The last question that, let me check, I have some notes about the last question. Oh, yes. The last question is about a feature we have in DAX.do, which is the following. You see that DAX.do has the visualization of the diagram view, which has the ability to represent tables, columns, and relationships in a way that gives you more control over the layout and the look and feel. Now, this is the question is, can we reuse this diagram for our own databases? Now, today, the answer is no, because for the same reason, what we see here is another set of information we receive from the service. In this case, we received the definition of the layout in a JSON file. But we discovered that the development we made to adapt this visualization, which basically uses a JavaScript library, a generic JavaScript library that has been customized to display diagrams for Power BI. But the idea is that it would be useful to create a version of the diagram that doesn't change just because you change the version of Power BI or Visual Studio, or because you move between Visual Studio and other parts. That's a problem we struggled a lot in the past. When you create a model, the diagram is not part of the model. It's always a separate entity. That for DAX Studio is a particular format. For Power BI is stored in another format. But when you publish the model on Power BI Premium, you lose the diagram view. And when you download, you no longer have the diagram view. So the diagram view could be important. So we are evaluating how to reuse the technology we have here to enable creating the diagram view for your own database, of course, not with DAX.do, but with something else. Because the idea of having an independent diagram that I can move back and forth without worrying about the version of or the tool I use to create a diagram could be actually a good idea. And so if you think that the diagram view could be just a feature to split in some other tool, just send us your feedback about that. We would be interested in knowing more. We have some idea, but nothing is written so far, and it's not something we will do in the next few days or weeks. It takes time. But I hope that this quick overview of the architecture of DAX.do helped you understanding what is behind the scenes and replied to many questions that we received. Thanks for watching this Unplugged video. Enjoy DAX.